Hey YouTube! I am going to show you today how to build a $25 aquarium light that is capable of growing corals and plants. If you want to skip my ramblings, feel free to do so. There's a link in the description. Also, there's links to the parts and some other research materials in the description as well. Continuing, I'm doing this because while browsing aquarium forums, I see all the time people asking the same question: what light do I need? Everybody asks it at one point in this hobby. So the answer, at least the obvious answer, is, oh, hey, let's go get a really cool, premium brand light. The trouble is, those lights usually cost a lot of money, $100, $200, even more. Now, that's not always practical for beginner hobbyists because I don't know if I'm going to like this hobby. Likewise, if I have a small tank, which are actually very popular right now, I only need a few LEDs. A lot of those lights are simply overkill. So then we move on to, all of our eBay and Amazon searches, which usually turn up, various black box lights, which are usually overkill, and I don't know how well they're made, and the coloring on them usually isn't very good. Things like PAR 38 bulbs or PAR bulbs, and then also SMD-based strip lights are also another option. But again, it's kind of hard to tell. It's like, well, is this going to be powerful enough to grow corals? You don't really know until you get the light. The thing that I like about do-it-yourself is that you know exactly what you're going to get because you're building it. You know that it's going to be powerful enough. And really, it's not that hard. With a little bit of research and some very basic electronic skills, you can put together a very cheap and effective solution for lighting your aquarium. And that is kind of the focus of this build, because if you look at a lot of the other aquarium light tutorials out on YouTube and things, they usually involve like LED strip lights, like the kind that you roll up in a spool, or they'll involve like an array of regular light bulbs that you maybe modify, maybe don't, but you screw in to a fixture. While those are great for lighting an aquarium, they don't really provide enough power for growing corals or plants in many cases. So what I'm about to show you is specifically for a light that is $25 that is able to grow corals and plants with the right size aquarium. Now, it's important to note that the aquarium size that I'm talking about is something between, say, 1 and 5-ish gallons. Also works best for a cube form factor, not a super long tank, although you could arrange the LEDs depending on the size heatsink you have. Now, this could be scaled probably to work on a larger tank, but that's not really the purpose of this video. I did the research for this tank, or for this light, because I have a Fluval Spec 3, which is a great tank. I love it, but the stock light isn't powerful enough to grow corals, and I've demonstrated that on a couple, like zoanthids and things like that even, that just seemed to not do well in this light. And I had done some research on various ways to accomplish a small LED do-it-yourself light, and I was ready to buy a bunch of electronic components and solder them all together when I came across a thread on theplantedtank.net, which had this solution, and the link is in the description. But I thought it was very nice because it was just one part that you could order, minimize the amount of soldering that you had to do, and also gave you a nice project box at the same time. So again, this is for a light that would be, or this is for a tank that would be somewhere between 1 and 5 gallons. You may be able to get it up to like 8 gallons if it's, a cube and it's still only maybe 12, 13 inches tall, something like that. Finally, I wanted to note that this could be really good also for a few specialty applications. What immediately comes to mind is something like a refugium. You could put some red LEDs in this, stick it over your sump in your cabinet, and be done with it. It would be a very good light for that. Also could be useful in a do-it-yourself algae scrubber. And the other thing that I thought of was glowfish. Now, while you can buy glowfish lights, maybe you want something that's more powerful. Anyways, you've stuck with me for a couple minutes. Now let's get on to how to actually build the light. Real quick, before I get into the actual build, I wanted to show you that the components are actually very similar to what you would get in a commercially available unit: a power supply, a control box, and the actual LED fixture itself. If I plug it in real quick, you can see that the dimmer is a 0 to 100%, and the idea would be that you would set the dimmer to the brightness that you want, and then you can plug the power supply into a standard wall timer like you would use for a Christmas tree or something, and that would control when your lights turn on and off throughout the day. So I'll do a demo. So it's off. There, it's just kind of barely on, and all the way up to 100%, and somewhere kind of in between, and then back off. So this kind of shows how it works. Next, I'm going to show you what you need to build it, how to solder inside the control box, then to install the driver, and finally to solder up the actual LEDs. So stick with me. Alright, just to go over some of the materials that we'll need to build this light, we need a soldering iron and some solder. We need electrical tape, some double-sided tape. We need some sort of power cable. I just took an old cell phone charger and I'm going to cut off the cable from it, but you could use speaker wire or whatever kind of wire you want. You'll need wire strippers. You'll need a screwdriver. You'll need a heat sink. This I just got off of an old computer, and I'm sure you know somebody that has one of these lying around. If not, they can be ordered online pretty cheap from eBay and things. But if you look at the bottom of this, you can probably fit 4 or 5 LEDs if you really crammed them in there. To attach them to the heat sink, you are going to use either drill holes in there, or you will use some epoxy. Either way, you'll need some thermal grease. So what you do is you put a little tiny amount of the thermal grease on the bottom of the LED, stick it down, kind of wiggle it around a little bit to thin out that layer, and then you'll screw it down, jam some screws in a hole, or take a little bit of epoxy and just dab it around the LED while you kind of press it down. You don't want the epoxy to get underneath the LED, but to hold it down from the sides. Alternatively, there is a product called thermal epoxy, or sometimes it's called heatsink plaster, which is an actual adhesive that has thermal transfer properties that you can use to permanently affix the LEDs to your heatsink. Now, for this particular project, I would avoid using bar stock, just because it's not very good at dissipating heat. These fins are really helpful. It gives it a lot of surface area. Also, this big thick base of aluminum is going to suck up a lot of heat from the LEDs. For this size heatsink, I would probably say you're okay to run it with 3 or 4 LEDs. But if you get any more than that, you kind of want to test it out, because you may need to leave the fan on it. Definitely if you have 5, I'm thinking that this heatsink will need a fan. 3, I think you're probably safe. 4 is iffy. If you do use bar stock or some lesser heatsink, you may need to wire up a fan, which adds some kind of adds some complexity to the project. You could always take 2 of these heat sinks and glue them together, or somehow attach them with, maybe some bar stock going across the side if you really wanted to. As for things that you don't have lying around, in all likelihood, you'll need a power supply. This happens to be a 12 volt 2 amp power supply. You could also use up to, well, you can use up to a 24 volt power supply. These are super cheap on eBay, Amazon, whatever. This connector came with an LED PWM dimmer switch. So this, you can find them online. They're only a couple bucks. To find it, search DC 12 to 24 volt 8A LED dimmer, and you can find a couple of, or find one of these here pretty easy. Mine has been modified a little bit, so ignore this cord for now. You'll see that in a second. Next, you'll need a Meanwell LDD driver. These are found online pretty cheap. This one is 700 milliamp, LDD-700, and HW. That's hardwired, so you want one that has wires. Finally, you'll need some LEDs. These aren't the actual ones that I used, but they're representative. I used Cree XTE, and I used one neutral white, 4500K, and I used two royal blue. Okay, next is what you want to do is open up the dimmer case, and you'll want to take your LDD wires, the red and the black one, and you'll want to solder them to the inputs where the power cord goes. To tell which ones to use, just use the V minus and V plus. The V minus is the black wire and the V plus is the red wire on the inside. Don't solder anything to the outside. Then is what you'll do is you'll locate this piece right here, and on the left gate, I believe it's referred to, you will solder the white wire from the Meanwell LDD to that wire. Here is a better picture, maybe. Alright, once you have done your soldering, go ahead and take your LDD driver and just use some double-sided tape and just stick it to the top here, just like I've done here. It sticks it pretty firm, and you don't have to worry about it bouncing around or anything like that. Go ahead and reinstall your circuit board after you've done your soldering, and all you have to do then is I went ahead and I took my power adapter, the one that I bought, my 12 volt 2 amp, and I just lopped off the end because the dimmer switch came with this cool connector piece here. So I took that piece and I just drilled a little hole in the corner here and stuck it in there and used the zip ties to secure it so it can't pull out. And then just take the yellow, which is the positive, goes to the red, and the blue goes to the black, and just connect those to this plug right here. Once you've done that, you can go ahead and put this thing back together. Alright, so we are done wiring up our control board completely. So move that off to the side. Next would be to wire up our power supply using the adapter that came with the control board. Just wire it up per the schematic on the board. Last step is to solder up the LEDs. So first off, I had another barrel jack that I soldered onto my cell phone charge cable, and this allows me to plug it right into the barrel jack that we installed on the control board. Alright, so now we're going to solder up the LEDs. Notice that I have kind of a special LED here. This is what's called a 3-up board. And there's essentially 3 LEDs, these 2 royal blue and that 1 neutral white, that's all on the same board. Honestly, it doesn't really matter. You could just as easily do this with 3 separate LED boards with just 1 chip on each board. it would work exactly the same. We're going to wire these up in series. So here's kind of a drawing of how that works. Essentially, the positive wire comes in from the control board, and you solder it onto the positive pad, which you can see right there. It's marked positive. Then you'll take a little piece of wire and you'll solder it from the negative on the first LED to the positive on the second LED, negative to on the second LED to the positive on the third LED, and so on until your string is completed. Then the last negative will go back to the control board. A few things before we move on. It's important that we match the forward voltage on the LEDs. So be careful of that if you're mixing brands, that they have the same forward voltage. I chose all XTE, Cree XTE, because they have pretty similar forward voltages for these LEDs. Alright, and to wrap it up, I guess if I were to do this again, I would probably just go ahead and buy a 24 volt power supply. I'd get a 24 volt at 1 amp or something like that. That should give us enough power to do 6 LEDs here. And even if this is 24 volts and you only have 3, the driver in here will only send enough power to the LEDs that they actually need, so it won't overpower them. But it would be nice to have the 24 volt power supply so that if I ever wanted to add more LEDs, I could without having to buy a new power supply. One final note, if you did want to increase this even more, scale it up, I believe with one Meanwell LED driver you can drive up to, say, about 14 LEDs pretty safely. If you wanted to do that, is what you would have to do is get 2 power supplies. Have one that would power just the dimmer circuit, and then you'd have to have another power supply that would go to the LEDs, and then you would connect the negatives together. If you go to the thread in the description at theplantedtank.net, there's a schematic of how to wire that up if you wanted to do that. Anyways, I hope you enjoyed the video and learned something, and hopefully you'll go ahead and build this light and if it suits your application. Thanks. Bye.